Emission spectra. Atoms and ions in the form of a gas can produce spectra in or near the visible part of the electromagnetic spectrum, both by absorption and emission of spectral lines at well-defined frequencies. Therefore, these atomic spectra and emission spectra are one of the most important tools used to investigate the quantum mechanical nature of matter at the atomic scale. In this experiment, we will use a diffraction grating optical spectrometer to measure the wavelengths of spectral lights emitted from spectral lamps, the apparatus. The light to be analyzed must pass through the grating as a parallel beam so that the direction of all rays will be the same and can be measured. The primary parts of the spectrometer are collimator. A slit and a converging lens are located at opposite ends of the collimator tube. When the slit is illuminated and positioned at the focal point of the lens, parallel rays of light will exit from the lens. Table. A central horizontal shelf for mounting either a prism or a grating. Telescope. An objective lens focuses the entering parallel rays in a plane so that the real image can be observed with the aid of the eyepiece. Crosshairs located in the focal plane of the objective lens provide a precise means for locating the direction of these rays. Vernier scale. A circular scale of 360 degrees can be anchored to the arm that supports the telescope. This allows you to determine the angular position of the telescope relative to the collimator from the reading of a vernier scale fixed to the base of the spectrometer. Now the spectra are. The mercury spectra. The most intense lines in the mercury spectrum are in the blue and green regions, which give the light from the mercury lamps its characteristic color. The hydrogen spectra. Hydrogen is the simplest element with its atom having only one electron, therefore its spectra has a discontinuous line spectrum consisting of several sharp lines is obtained at visible wavelengths. The neon spectra. Neon has a very rich spectrum dominated by red lines that are responsible for the beautiful red glow of neon tubes. Thus, the wavelength of spectral lines are obtained by calculating the corresponding vernier angles of each spectra.